Um, First of all, I would like to introduce you our first speaker. So we're gonna do a little change of schedule. So we're gonna start with Michael Coté. He's a senior member of technical staff at VMware. He's a book writer as well. So changing mindsets and monolithic transformation are a huge impact from him, and he will show us today how we can manage some legacy applications that we're probably all facing at some point. So, Michael, you have the stage.
Well, hello. Thanks for having me here. It's always nice to come out and talk with people. Well, as mentioned, I'm Coté. You can call me Michael if you want, but that's usually what my wife and my mother call me. Not always when I'm in trouble, like I was when I was a kid. But what I'm going to go over is, as mentioned, how people are dealing with the legacy software, how they're doing application modernization in their large organizations usually. And being at the DevOps stage here, I'm going to look at both the developer side and the operations side of it and see what legacy means there and how people are modernizing it. Now, it's based on a short booklet that my friend Mark Zotner and I wrote now a couple of years ago, going over the methodology that we've participated in and seen over the years to help people really figure out what to do with their tech debt and their legacy software, how to get it modernized. Now, why is that important? Well, this is kind of a jokey example that may or may not have actually happened to me in real life. And I think it represents a lot of why managing your legacy software is important for organizations. This is a commercial way of doing it, but you can think about like if you were in a government or a nonprofit situated organization, similar things come up. And it starts, of course, with application developers. Now, I used to be an application developer, and our estimates for how long it would take to do anything was basically a weekend, right? This is kind of like the, I don't know why you would want to work on a weekend. We were young back then. But it doesn't take that long to just write a few lines of code and deploy the software. And so in this case, let's say you might be going to the beach on a little vacation, and you just bought one of these fancy, very expensive new phones, and you want to play with your kids. You might want to take pictures, text with your loved ones about where to have lunch. And at the end of the day, after playing with your kids, making sandcastles, you find that you sat down in the ocean with your phone and it no longer works. And this is a not fun situation. But if you think in terms of business opportunities, that's a great opportunity for insurance companies, right? To sell 24-hour insurance, essentially, to insure your phone that if something goes wrong with it on your trip, you can get it replaced. It's probably a great business because most people probably aren't as silly as I was to sit down in the ocean with a phone. So it's sort of a stream of free money if you can manage it. Now, that kind of business, especially starting it up, is driven by software. And it's probably, you go talk to the developers and they're like, I don't know, what's it going to take? One screen to collect some demographic information, one back-end call to like see if they can buy the insurance, and then get their money. And sure, there's a claims process if things go wrong, but we'll worry about that later. So it'll basically take about a weekend to code, or a week, just from a coding perspective. Now, of course, you can imagine how the story goes. The first thing you encounter is you've got some sort of back-end system you need to work with that you haven't really interfaced with, and it may be running on a mainframe. You're not sure. It has some strange way of, some strange API that you have to work with just to collect the information and see if you can sell that insurance. And then, of course, there's our operations friends who are going to want to know how you're going to run this, how you're going to package and configure it. You probably need to have a meeting with them. So whenever they get back from vacation, you can schedule that with them. Then, of course, if I'm living in Amsterdam and I want to buy insurance for going to, I don't know, Alabama or Romania, how does that work as far as compliance, as far as going cross borders and things like that? So we've got to involve the compliance person or at least an interface with them. And all of a sudden, your week has expanded into months and months. And not all of that is due to legacy code, but a lot of it is due to the lack of modern ways of doing things, of having a lot more automation, and then as with that, interfacing with APIs or knowing the code, kind of dealing with older code that you have. And this is a situation that comes up with the organizations I talk with over and over again, where there is this simple idea that they have, and it should be relatively simple to do the application, but it's all the other stuff outside of actually just writing the code that pulls these organizations back. Now, here's an estimate that I more or less don't really believe, but if you bring it down an order of magnitude or so, you can see that there are a lot of these legacy applications out there, right? This is an estimate from IDC, big numbers-oriented analyst firm out there. And I don't know, maybe 500 million is good. I should do some spreadsheetery in my head. But there's many millions and millions of legacy applications and services out there, right? I'm sure if you're wise enough and disciplined enough to come to this stage, you probably have no problems here. But if you were to talk to other people at other stages, maybe they have lots of these applications they're dealing with, so you can help them out. But you see the magnitude of the legacy systems out there, and it starts to match what we kind of anecdotally know, the conversations that I and probably you end up having about it. And then on the business side, right, thinking about building that insurance application so I can get a new phone once I dunderheadedly sit down in the ocean with it, you can see surveys show that the executives, the business side, they suffer from this legacy thing as well, right? So just over 75%, we'll say 3/4, if you like putting it that way, of organizations are saying that this legacy problem we have is holding us back from doing things, from evolving our business, just adding new features, whatever it may be, right? There's issues that are there as well. And again, this kind of matches the intuition that I think a lot of us have. And then, I don't even know if it's increasingly, but this has always been a problem, is a friend of mine calls it the N-0 problem, which is to say, if you look at the various frameworks for applications, the infrastructure that you're running, what version of that are you running, and how many versions behind is it? Because in our ideal state, we want to be running on the current version, the N-0 version. But as just looking in kind of the Java world, at the Spring world, you can see that most people are running several versions behind. And as support windows close, it's always nice to have support. Not only are you losing support for those applications, in places like insurance companies and banks, this is very important, not to mention governments and other organizations like that. But you're also missing out on new features that get added to this, right? The older the frameworks and the older the infrastructure that you use, the less chance there is that new features you'll want to take advantage of will be in there. So we've got these three sort of sources that kind of show there's a lot of legacy applications out there. People are saying in surveys that it's slowing them down and holding them back. And I think if you kind of look at all of the assets under your management, the applications, you'll also find that you're struggling to keep them up to date, that they're going down this kind of vicious cycle of being legacy software. So this is me. As said, I get the chance to study how large organizations work or don't work. That's always more interesting. And I've been lucky to work at Pivotal Software, now VMware, recently purchased by Broadcom. So I think I'm supposed to say VMware Tanzu by Broadcom, which is a very long but descriptive name. I've been an industry analyst at several places like RedMonk. And I've gotten the chance to write some books. I do a lot of podcasts and things like that. But a lot of the focus of what I do is on software development, kind of the strategy of how organizations use their software, and plenty of kind of DevOps-y infrastructure sort of stuff. So as my colleague used to say, engage with my brand, or not, whatever you may enjoy. So let's first look at the application side of it, the dev side, which, just as a side note, I always think I've been, I won't say in, but I've been on the periphery of the DevOps world for a while. And it's an interesting thought exercise to say, when is the last time you talked to a developer in a DevOps conversation? It was sort of more like ops is what things have turned into, which is fine. It's no problem. But let's delve a little bit up the stack, so to speak, not in a pejorative way, to what the application developers are up to, how they're dealing with application modernization. Now, obviously, this is a lot to read in one slide. That's why you can download the slides and look at it in detail. But what I'm going to go over is just a methodology that we have been using for, I think, 10, 15 years, starting at Pivotal Labs and Tanzu Labs, called the Swift methodology, not to be confused with the Swift programming language. But what I'm going to walk through is how you apply, to use the word again, a disciplined approach to thinking about all the applications you have, selecting which ones to modernize, selecting which parts of those applications to modernize, and focusing on getting started with important things rather than doing everything at once, right? Rather than having a very optimistic idea of everything that you're going to do. It's good to start small and go through this. And we'll go through that analysis and look at how people have been applying it. Now first, from an application developer's perspective, let's ask what legacy code is. I mean, I think we kind of have an intuition of it, but it's always good to have a definition. There's kind of three ways of thinking about it. One, we'll start with Ann Thomas, great Gartner analyst there. And you can see that she's describing what we've gone into, is that the systems just aren't up to providing the new functionality that you want. You can't really change them around. They're stuck. And then, of course, Michael Feathers, who, if you're into development, he wrote this great book, I think in 2001, which there hasn't been subsequent editions of it, which shows how applicable it is, all about working with legacy code. And his overly clever way of thinking about it is, to go back to it, let's see, is that essentially, if you have legacy code, it means you don't have unit tests for it. And this is, like I said, clever. And that kind of leads to my way of thinking about it, is it's code that you have to change that you're afraid to change, right? If you had tests, you could change the code, you could run the tests, and you have a pretty good chance of seeing if you broke it or not. But a lot of times, the legacy apps that you have, they either don't have tests, or you don't really trust them, or whatever. So any change you make, you have no idea if it broke things or not. And so I think that's a good way that developers start to think about it at the code level, but also at the level of, like, what is it stopping us from doing? Why is it such an issue? And then looking into what it means to be like kind of caught here, right? Like, again, we have an idea of this, but I think especially when you're thinking in a large organization, how are we going to propose working on it? It's good to have a kind of an overview of what you're suffering from. And the first one is, what I've talked about so far, is that it stops you from doing much, right? You're spending a lot of your time on maintenance, on that technical debt, compromises that you've made instead of doing the ideal things. You spend, some people estimate they spend like 70 or 80% time just on maintenance instead of new features. This is especially true in the infrastructure stack. The other thing that you get to kind of summarize the next two are, if you don't trust a system, as a person, you often put a lot of governance in place, which means people checking on things, which means meetings and documents, right? So the less trust you have in a system, the more you want to have manual verification that it works. And so this often, again, it creates this vicious downward cycle of more and more meetings, right? Because we don't trust the code, we don't have it automated or the processes, and then you end up having all of this time that you have to spend basically verifying and governing things. Now, you want to govern things, but you want to automate those, as we'll get into, a lot more than having actual, let's say, manual meetings for them. Then, how does software go bad? There's all sorts of ways, but there's three things to think about. One is the fitness that we've talked about so far, which is just its ability to satisfy whatever needs you have. And for a very old example, I remember back at the end of my development career, mobile applications were just becoming a big thing. And there were many existing applications and services that just didn't match that way of doing an app, right? So the fitness wasn't there. Nowadays, you can think about if you want to apply AI to something, or you want to kind of deploy in some new region of new sort of laws that you need to follow. There's a lot of fitness that isn't there. The application isn't capable of doing those things. And this can be caused by that debilitating tech debt and other things like that. But you need to add features to the application. Now, there's also, another side of that is the capability that you have. But this can be performance characteristics or the ability to certify with something. This is a lot more infrastructure-based than necessarily the features that you have. And then a very common one is that you've just basically, at an organization level, forgotten about it. You're not really sure who wrote this stuff. There's not really great up-to-date documentation. You maybe don't even know what this part of the system does, and you're not sure what's up with it. And there was some, I think it was at JP Morgan Chase, big global bank, and I think I read somewhere recently that they got rid of several hundred, if not low thousands of applications, which is kind of a sign that people had forgotten about them, right? That they weren't necessarily something that was important. And also they had rewritten them and modernized some of them as well. But these are the things that often come up that my colleague Mark and I found when we were thinking about what is legacy software and how does it go wrong. All right, so let's look at the process of how people start to modernize these applications. So nowadays, I don't know, we broke it out into 7 R's, and it's great to have an odd number of words that begin with the same letter. Originally, Richard Watson over at Gartner came up with 5 R's, but as time has progressed, we've added more to them. But this is kind of the options that you have, things you'll often end up doing if you're modernizing, right? There's the retain, which also should be called the do nothing and hope it works out. But maybe that makes sense in an analysis that we'll go into. There's that retire, right? If it's not used or it's not really worth what you're doing anymore, you can just stop using it. A very popular, maybe the most common thing that's happened over the years is rehosting, which is you just move it from one set of infrastructure to another without really changing the application around very much, right? So this is what you see in the ongoing push and pull between moving on-premise and public cloud and moving from public cloud to on-premise and various data centers and regions, right? You're focusing on the compute that you're running it on. Then there's replatforming, which is a little bit more up the stack, right? So here you might have the notion of we're going to move to a VM-based way of doing things to a containers-based way of doing things. We're going to move from more of a traditional 3-tiered stack to a Kubernetes type of situation and move the application over that way, but we're not yet going to spend a lot of time on the application code, only what's necessary to run in a different kind of platform. Then, of course, there's the part that, even though it happens the least frequently, I think we think about the most, if that wording makes sense, in the modernization world, which is the final one, refactoring and rewriting. Now, I know there's a difference between refactoring and rewriting, which is great, but I'm just going to lump them together. Otherwise, we'd end up with 8 R's, and that's too many. So what this means is a lot of what the focus of what I think is interesting in this Swift method that I'll go over which is actually looking at not only writing new code, but even redesigning the applications to really make them more modern and kind of address the fitness, the capability, and the forgottenness, if that's a word, that's created them and made them legacy. Now, there's also the option that I skipped over to just replace it or repurchase it, right? You can outsource this to someone else to manage. Maybe you can even just replace it with an application, a SaaS service, right? Oftentimes it turns out the customization you needed, you don't need anymore, and you can just replace it with, like, I don't know, maybe hire someone who knows what they're doing in Salesforce and make a report for you or something like that. Like various sorts of things like that where you can replace all sorts of code with something more off the shelf or off the web. So let's look at that, as I was saying, kind of like the analysis that you go through when you determine those 7 R's, or 8 if you want to separate out rewriting and refactoring. So as always, when it comes to kind of portfolio analysis, doing some sort of technical analysis with a business flavor to it, you start with a 2x2 matrix. This is what you're always going to have. 3x3 would be too much to think about. But here, one of the axes is if you'll pardon the phrasing, business impact. You could say business outcome or value. But it's just like, is this going to help the organization? And to what degree will it help the organization? Is it valuable to them? And then on the other axis, you have technical feasibility. And this is a rating of how possible is it to do it in a reasonable amount of time. If we actually work on this application or this service, do we have a good chance of a success rate? So what's key about this is not only the categorization of it, but having a workshop with several individuals. Maybe it's a half day. If you make it a full day, you got time for lunch, so that's nice, and you can hang out. But a full day, a half day sort of thing. And it's not only your developers, but also infrastructure people, hopefully some governance or security people, but very importantly, people from whatever you want to call it, the business, right? People who this application is helping run their part of the organization. So you get these people in a room, and or online, if you want to do it that way. And what we've done over the years is you just get sticky notes or Post-it notes, if you don't mind trademarks. And you get these people to write down applications they think should be modernized. Maybe they thought about it ahead of time or not. And then you have each individual place that sticky note on a board somewhere where you've drawn this out. Now, what's going to happen is every note is going to be in the upper right-hand corner. because whatever they wrote down, they think is the most urgent and most important to do. So what you do is you draw the lines and you force them to do it again until what emerges is, let's say, 2 to 3 applications here in the corner, right? Now, of course, there's conversation here, going back and forth to rate this stuff, to explain it, but what's very valuable about this process is that you've gotten involvement and commitment from all those various stakeholders in the room. They all collectively think it was their idea, which it was, right? So you can really speed up a lot of the time it would take to convince people in the organization, talk with them, often battle with them over priorities, because you've involved them from the beginning. So it's a very simplistic process. And kind of during the workshop and during the day, you're going through these criteria, right? You're filtering down to just a couple, if not just one application or service to start modernizing, right? And the technical people bring sort of capabilities and considerations. The business side of the people think about like not only the I guess money-making potential, like how it's valuable to the business, but also the kind of risks that are involved in it, right? Like prioritization, all of that fun business stuff that they focus on. And you end up kind of sorting out like, excuse me, which of those 7 things would be valuable to do, right? So it's a good framework for thinking about, for drawing up the idea of what you're doing. Now, I'll give you an example of what it looks like after that. This is an example from a pharmacy about refilling your prescriptions, right, or your medicine. From an end user standpoint, from my standpoint, it's pretty simple. I get the prescription, I give it to someone behind a desk, and they give me pills, right? And depending on how I pay for it, things are slightly different, but it's pretty straightforward. But one organization we were working with, they were looking to add what you would call omni-channel, not just a desk, but you've got to drive up, you want to refill on an app and pick it up at a locker, maybe you pick it up at the curb, whatever. All sorts of ways of doing things. And they found that their overall system for refilling prescriptions wasn't capable of doing that. It didn't have the fitness for it that they could just easily add these things on. Not as ridiculous as frying your phone in the ocean, but much more valuable that they needed to add these things. So after going through that process, the first thing that the architects and developers and even infrastructure started doing is looking at all the workflows in that process of doing things, right? So again, I just went over one workflow. I'm a person, I get the pills. That's it, right? But there's actually all sorts of things behind the scenes happening, right? Checking for the safety of the medication, making sure you're authorized to get it, collecting the money, however you might do that directly or through insurance, calculating the prices based on weird things, all sorts of stuff that's involved in that seemingly simple process. And the analysis that you go through with event storming and then further processes in the Swift methodology breaks it up into these services and things that happen there. And then, as you can imagine, you further break out into the, if I remember correctly, the bounded context that you have, kind of the areas of your system that can start to act independently, right? And what you're doing here is you're almost rediscovering the system and re-architecting it based on what it's currently doing and what it needs to do. And as with all great development, at least last time I was doing development, I assume this is true. When you break it into these independent components, it's a lot easier for you to improve those components and therefore improve the overall system. So eventually what ends up happening is you pick a few of those things that are standalone enough, and you can start to rewrite and redo those components to fit in the overall system of how the prescription system works. Now, one of the most important things, two of the most important things here is that you actually get started doing something, right? So you don't spend a lot of time analyzing the entire system, every single thing, writing out the design documents and planning for how to modernize everything at once. Instead, you're doing a very minimal amount of breaking up the subsystems and starting to modernize it. And what you generally find when you're doing this work is you really had no idea what you were doing, nor could you predict what things that you would encounter, issues that you would have. And so you need to start and experiment with things to figure out not only the code itself, what's in the components, but all of the dependencies that you'll have in the organization, not only with systems, but people that you'll be interacting with. But you also want to start actually doing something, because if after 12 months you haven't done anything, probably what's going to happen in the new budget cycle is people are going to say, you haven't done anything, you haven't actually shipped anything, and then that's just going to cause more spiraling and more problems. So you want to pick something that you can start to do immediately. Now, I know you can't click on it now, but when and if you get the slides, I'd recommend reading this write-up. It's a great case study of just any type of modernization that you might be doing, especially one in a kind of a business context. I'm not sure how you modernize services where you take a picture of your sandwich and share it with your friends or complain about your neighbors, but maybe it's similar. I'm not really sure. So now let's look at the ops legacy stuff, right? Now, with operations, a lot of the legacy is about the tools that you're using, especially the process that you're providing to the application developer and the tools that they're using, but also about how you do your job yourself, the people side of it, which I think is equally important to look at. Now, especially here at the DevOps stage, I think the first thing that you want to do is ask yourself, if we are doing DevOps or platform engineering, if we are, our role is to help the application developers in our organization ship their software at the best quality the most frequently. I mean, frequency is kind of up in the air as far as it's important, but we want to have the ability for application developers to ship, to add new features, and we're supporting that. It's good to go back and say, okay, are we following the practices that have, more or less been proven over the past 10, 15 years or so? And I like to highlight this slide because if you've read the DORA, the DevOps research, I forget what A stands for, but if you read those reports over recent years, they're great. If you follow DevOps, things are going to improve. You're going to be an elite performer. Who wants to be a low performer or in a terrible Westerem column? But if you follow these practices, you at least have a chance at operating better. Now, oddly enough, despite having 120 pages in the most recent DORA report, they don't actually have this diagram. But if you go to their website, you can see these are the capabilities that they have mapped out. These are the behaviors, the things that you do. So that's the first thing when you're doing an analysis of sort of the legacy situation of your operations organization, is just look at this and say, do we do those things? And I always recommend, don't necessarily just ask someone, go investigate and figure out if they're actually doing things. And a great way that I learned from my friend John Willis to test this out is talk with some people for a while, kind of get their trust, have lunch with them, and then ask them to tell the story of the last time something went wrong in production. And of course, what you want to say is, so I assume something went wrong in production, and the first thing you did was you looked it up in the CMDB. And that usually will set someone off to be like, no. The first thing you do is email Alice. And then you're going to start uncovering the real path of how things are done. But start with that. Are you following the best practices, which are easy enough to find? And maybe you adapt them, whatever, but it's good to have a template, defaults to start with. So speaking of one of the practices and the defaults, this is, I think, probably the most important thing for any organization to do who wants to improve how they're doing software. And I say that because automating your builds, automating your tests, and if you really want to, automating your deployments. And I guess when you think about automating your deployments, that's really focused on operations productivity. It's having that same kind of automation for all the configuration, the packaging, the deploying, the instrumenting, all the stuff operations people, you're automating that. I mean, as a side note, we've been obsessed with developer productivity for many years, and I feel like maybe the operations people should get some attention. Operations productivity would be nice to pay attention to as well. Anyhow, this is a survey going back for, I don't like to do math in public, but for some time, asking people if they have continuous integration and continuous delivery. Now, there's two things you should see here. One, not that many people do, about half of them, which is, depending on how you think about things, a lot or a little bit of people. Now, it's also been flat for many years, right? So there haven't been a lot of improvements, a lot of growth in people adding in build automation. And then you also see that continuous delivery has slowly been creeping up. And in theory, you can't do continuous delivery or deployment. You can figure out the difference if you really care, without having build automation. So I guess that will always be trailing. But you see that these end in 2021. So things must have improved in, I can do this math, 3 years. But if you look at this is from the CD Foundation, the people who did that survey, they've been through a few private equity hands and probably are optimizing their marketing spend, so they don't do that survey anymore. But the CD Foundation, the continuous delivery or deployment, or whichever one, they started doing the survey around the same time, and these numbers are a little worse, so I don't know, I would adjust them based on the past ones. But you can see on the bottom, these are the people that are saying that they participate in build automation and build testing, automated testing, which hopefully that should be all developers, using automated testing and participating in automating their builds. But you can see that there's a shockingly low amount of people who have been automating it, right? In case you're like me and you don't like doing math, I've highlighted the people on top who don't do it. And I made it red because red is generally considered bad, green good. So you can see that when you look at surveys, and maybe even if you match it up with your own anecdotal experience, there's not a lot of automation going on out there. Or to put it another way, there should be a lot more of it, right? So if you're looking to improve the way things are going, both for developer productivity and operations productivity, I would just look at that first, right? Again, go out in your organization, figure out how much build and test automation you have, how many applications are actually on those pipelines, and see what's happening, right? Ask that question like, so what do you do when you need a release? I assume you just click a button, and in a few hours it shows up in production, right? And then see how people react to that and answer that. Again, just kind of hang out with them, see what's happening, and track that down. Now, the other thing that's especially emerged in the kind of last, I guess, 7, maybe 5 or 7 years of kind of cloud native and Kubernetes distraction is we've really not focused much on building platforms, on platform as a service. And instead what we focused on is coming infrastructure up, right? If we're going to deploy a container-based way of doing things. When I talk with a lot of infrastructure people, their view of a platform is that I set up these Kubernetes clusters, or I set up an automated way to get VMs, and then I'm done, right? Like essentially what they're delivering to application developers are a blinking cursor, right? There's not integrated middleware on there or tools. They really just see their job as providing self-service to infrastructure because that's what happens in the cloud, right? Now, instead of that being sufficient, what ends up happening is each group of developers, and maybe it clusters, they end up building a platform on top of that infrastructure, right? You need middleware. You need a way of automating the way you package and configure things. Oftentimes, developers are not so great at this. You need to instrument your applications so they can be managed and monitored in production. Again, not a strong suit for developers. You need security stuff. You need all of this stuff that you see in a platform. Now, the Cloud Native Computing Foundation, they have a great, last year, if I remember, they have a great reference architecture for what a platform looks like. And I think it's important to get that paper and study it. What's also great, they have a platform maturity model. If you want to look at the journey you can go through to get a platform. Now, of course, where I work, we have a platform, so I've highlighted that extra large here. But it's basically the same thing, right? You can see how you got infrastructure, how you package and deploy things and manage them, all the various middleware that's there, all the way up to the UI level, the frameworks and things that developers use, right? And what's important about each of these types of platforms is thinking about how much of it you want to have, where you want to run it. If you want to control it fully in on-premises in a private cloud environment, if you want to have a lot of control over it in a public cloud environment, or if you want to go all the way up to I don't even want to manage the platform, right? But what's really important is that you have a platform instead of just a bunch of accidental platforms. Because a lot of the legacy you're going to encounter, if you think about it, is all of those platforms are going to soon be forgotten and not have fitness. So centralizing and standardizing on them has a lot of benefits, the larger the organization that you have. All right, so what do you do with those platforms? There's a very important thing, and I think, if you remember, the platform engineering came in and killed DevOps. So congratulations to hanging on at this stage here. But, maybe only a little less snarkily. What is different about this idea of platform engineering running a platform than more what DevOps has come to mean is a notion that you build that platform I was going over, and very importantly, you product manage that platform. So you evolve and add features to that platform. You think about it as a product. And the first thing that you do when you're thinking about something as a product is you're thinking about who are the customers of that product, right? So this is the first step. The customers are the application developers. So then the next thing you ask, especially if you're an operations person, is when's the last time I talked to an application developer, right? This goes all the way back to, it's not a lot of dev and DevOps, right? And more importantly, not only when did I talk to them last, When did they tell me a need or a feature that they had that we added to the platform? And when did we pay attention if that need was satisfied or we needed to work on it some more, right? And this is product management. You add product management to the way you're doing operations. Now, there's a lot written about that in the past few years. And if you look at companies like I mentioned JP Morgan Chase, Mercedes, NatWest, all sorts of organizations that you've probably heard of, they actually have this platform mentality, and they have product managers, sometimes they call them product owners, which sounds fancy, for their platform that are talking with developers, that are coming up with backlogs, features to add, that are working with the platform engineering team to add those features. Now, thankfully, product management is a very, in the best of all possible ways, boring discipline. It hasn't really evolved that much because it's almost perfected, right? You can go and buy all sorts of books, watch videos on product management. It's very straightforward, right? It's about as exciting as arithmetic, which I'm sure some people love. But if you're not familiar with product management, it's very easy to learn about it and start doing it, right? It's been made not an esoteric sort of thing like, I don't know, SAN configuration or whatever. Now, the important thing from a platform standpoint, if you're product managing it, is to start gathering information, feedback from developers. It's fine to do that, over a meal or coffee. Developers love to complain. It's one of their strong suits. And also what you can do, what I would encourage you to do is maybe starting monthly and then moving to quarterly, start sending out developer toil surveys. And this is, I worked with some of our people a couple years ago now to basically make free one of the developer toil surveys that we do. Again, you can't click on it, but you can read a paper going over how to do it. You can use these questions for free. But you do it on a Likert scale, 1 to 5. And if you think about asking these questions, you dump it into a spreadsheet and you sort by descending order. And what you end up finding are your most critical problems. That's maybe not the best way to do something, but it's better than nothing. And better than just going by your instinct, if you will. And what's important about that, why you do this survey regularly, is as you identify those things to work on that are slowing developers down, you then survey again and see if those items you worked on have moved down the list, right? You see if they've actually improved. And this is a vital part of product management that we in IT don't do so much, is ask, did it work? And if not, to fix it. So this is a very easy way to get, maybe not easy, it's a very possible way to get started on that kind of journey of addressing the legacy problem in the operations area, going all the way up to helping developers out. So to kind of summarize a lot of it, right? I think there's two types of legacy, two types of modernization that need to happen. There's at the application layer, where I think we all know that just code goes bad, right? Applications aren't able to evolve. And there's, what's important there is to pick a methodology, pick one approach. I think the one that we have is great, and it's free to use and easy to look up. But have one that you follow, right? And actually follow it for a year or two. If you've ever been through organization enterprise architecture projects and it changes every year, you're just like, this is not worth anything, right? If we keep changing the way we think about things and write all these documents, I don't know why we're doing much. I guess there's cynical reasons to do it. Anyways, have a process to think about going through those portfolios of applications and services that you have. And then think about, in the DevOps, in the platform world, the infrastructure world, whatever you want to call it, what are the legacy issues that you have? And chances are, process-wise, you may not be following all the DevOps practices. You probably have allowed all these accidental platforms to spread like weird fungus and mushrooms after several rainy days. And then maybe you're not thinking about product managing the infrastructure ongoing, the platform that you have. And hopefully that'll help out. Well, thanks for your time. It's always nice to come out and talk with people. If you want to get these slides, use all the links to look at stuff, that would be great. It makes me feel nice to see higher numbers than lower ones. But they're here, and I'll be around a little bit afterwards if there's any questions or conversations that people have. Thank you.
Thank you so much. I guess this is one of the topics that I'm really excited about because in banking we hit some legacy applications all the time. Yep, and yeah, it's a tricky subject in most areas because you are also alter some egos when you try to dig in and what's happening over there, especially if you're handling applications that are being developed in house and are legacy at the same time because it happens as well. You own the code, but at the same time, it's legacy. I understand that with off-the-shelf applications, but with your own code, that's a pity, a bit. Yeah. So you have to handle it with a lot of care. I'm curious if we do have any questions from the audience at this point. No. Yeah, thank you so much for the slides. I was taking pictures of them, but thank you for making them available.
Absolutely.
It's always a good idea, so I
Yeah.
greatly appreciate it.
All right. Well, good luck. Enjoy the
Thank
rest
you
of
so
the
much.
talks.